An audio signal will be digitized for transmission. Okay. If the channel capacity is 400 kilobits per second, so the channel capacity is given here, and the signal to noise ratio of the receiver, so SN ratio is 15 decibels, then the Shannon bandwidth is, so we have to find out the Shannon bandwidth. Okay. Now remember, the equation for the channel capacity equals to, it is expressed by C, is B times log 2 of 1 plus S over N. Now this S over N is unknown to us at this point, where B over here in this equation is the desired bandwidth. Sorry, this is not band gap, bandwidth. And this is what we are trying to figure out. But the first thing we need to do is to find out the S over N. And S over N, there's another equation, 10 times log of 10 of S over N equals to SN ratio. SN ratio being known, we can find out S over N. So let's do a little bit of math here. So 10 log of 10, and then we have S over N, and that this is given 15 decibels, correct? This is 15 decibel. I can rewrite this equation such that log of 10 of S over N equals to 15 over 10, and that would basically be equals to 1.5, correct? Now S over N equals to log 10 inverse of 1.5, and if you do the math over here, you will basically would get S over N, also be written as S slash N, equals to 31.622. I'm going to take this number right here and put it in this equation. Again, C is given, which is 400 kilobits per second. So you get 400 kilobits per second, the channel capacity, right? You also have B is what we need to find out. Log 2, and then we have 1 plus 31.622. 31.622. We also have 400 kbps equals to B, and if we solve this, if you use your calculator and get the log to 1 plus 31.622, you basically would get 5.03, which means the desired bandwidth B equals to 400 kilobits per second over 5.03, and if you do the math here, your channel bandwidth will come out to be 79.558 kilohertz. And that's your answer. That's your desired bandwidth. 79.558 kilohertz, approximately equal to 80 kilohertz.